Uh, Today we'll introduce the limit data in the empirical estimation. Basically, when we study in the field of labor economics or the labor markets database, because some questionnaire, their question or their problem, their survey, usually they have limited data. For example, basically some reviewer or some people, they do not want to answer. They do not want to answer their personal information, such like their income or their wage level. So sometimes if the questionnaire, if we ask the people and we ask them, how about your money in the last week? Do you earn? How about exactly the money you earned in the last week? And they may not give you the actual number. So the econometrics field, they call this is the limited data. So if we face this problem, so we cannot have the exactly statistical database. So if we face the exactly statistical database, basically if the sample is large, is in a large scale, then we can find a normal distribution. It's a bell shape. Basically it's like this. But if we cannot find the exact database, because these people, they do not want to share their personal information, so their database, we cannot face this distribution. So some questionnaire, they have to ask different problem, such like they set the interval, the question with the interval option. For example, they may ask the people, how about money do you earn in the last year? Then they gave their option. For example, the first option, your money is less than 10,000, or your wage level is between the interval 10,001 and into the $20,000, and then we can go up to find their interval level, their income in the interval level, and we call this, because this pattern we call this is a discrete data or the discrete number. And if these people, they want to share their real money, then we can find this bell-shaped distribution. Then we can find for example, some people, their wage level is less than, for example, their 9,000, or some people they have 50,000, like this pattern. So if we face this pattern, then we need to find another estimation or another empirical model. So today I'll introduce the concept of the binary or multiple choice. Basically, we sometimes may face that some people, they face the choice in the labor market or in their activity. For example, what your decision when you graduate from the university? You go to the graduate course, or you go to the labor market to work. So you have a binary choice. And so we can define dependent variable y equals to 1 or 0. If y equals to 1, which means these people, these people, he decide or she decide to go to the graduate course in the university, or they just graduate from the university and go to the labor market to work. And we can say that the number 1 or 0, it means their binary choice. So if we can observe large sample, or we question their large sample scale, then we can further test the probability. Then we can use this equation, the probability y equal to 1, which means if we implement the questionnaire and we ask these people, what your action or what your choice, y equal to 1, which means these people decide to go to graduate course, then we set this function. Probability y equal to 1, which means the probability of this sample, which these people they decide to the graduate course. And multiply their function. And the xi is the characteristics of these people. For example, their gender, their age, or their grade in the course grade in the university. For example, if they have a better grade in the university, they may have an incentive to go to the graduate course, or not to go to the labor market too soon. And we can find this probability yi equal to 0, and multiply xi, or we can say xj I do not equal to j. We can set this sample. So now we can use this equation to define the empirical estimation, and we try to find which character decide or affects their choice. As I mentioned, the first item, probability y equal to 1, which means these people they decide to go to the graduate course. So their character affects their choice. And y equal to 0, which means they want to graduate from the university and go to the labor market. So this character affects their choice. Then we can further to describe this equation like we can further to describe this equation like this one. Binary choice y equal to 1 or equal to 2 equal to 0. And this is the probability 1 minus the probability go to the graduate probability. Now we can to observe or collect this statistical data, and then we can use this figure. The horizontal line is a number. The database we observe, and the vertical line is the value of y. And in this equation, we only get two numbers, 1 or 0. Then we can use 1 or 0. Then we can find this equation or this pattern. The figure, then we can collect this figure or this number. Then first we can say they have many observations many people they decide to go to the labor market, or some people they decide go to study in the university. Then we can use the equation. We can use the equation, this figure, and use the estimation to describe or to estimate this pattern. And if we compare with the ordinary school, this square, this square, and in the previous course, we said if the horizontal line is the explained variable and the vertical line is the dependent variable, the phenomenon we observe, then we can collect every sample we observe. Then usually we use this linear function to capture this pattern. Then we just should find the minimum error. If we can set this linear function and with the minimum error square, then we said this linear function or this linear equation is the best. That has the best explanatory ability. But if we use this equation in this figure, you can find their error term is too large. So basically, if we face the limited data, basically we use the probit or logistic regression, because the pattern of the probit or logistic regression, their pattern is like this. Their pattern is like this one. They have like a S shape, and this shape can capture the number of 0 or the number of 1. And if we compare with these two patterns, the first one is an ordinary square linear function. This is a line, and next is an S-shaped line. Then the Oreo as ordinary square, this pattern, they have a larger error, which means they have much better explanatory ability. And the logistic regression, this equation, they have a better ability to explain this phenomenon. Okay, so then we can use this. Then we can use the screen. So in this slice, we can use this, the y equal to 1. As an example I mentioned before, if this labor, they decide to go to the school for further study, and or they just quit and graduate from the university and go to the labor market. So this equation is that if you start 1i larger, you start 2i, which means in the feelings of these people, this person, their utility, when they go to the university for further study, the utility is larger than the situation he decide to go to the labor market. So he decide to for further study. And if yi equal to zero, which means in this situation or in this phenomenon, people, their utility, they think go to the labor market has a better reward or better expected reward. So their utility to I star is larger than U1 star. Then we can use this equation. Is this like the ordinary square equation? The difference between the OLS or this binary choice model is this is not straightforward line. This is S-shape, more like a S-shaped line. So we use the equation, and yi is under some assumption, which means y is only 1 or 0. Only 1 or 0. Yi larger than 0 or yi lower than 0. So this is a pattern I described in before, and you can find the horizontal line is the sample we collect, the sample number we collect, and the vertical line is the number of y. So the green line is the ordinary square, the linear function, and you can find if we compare with the arrow term, and this arrow is larger than this S-shape equation. So let's say the blue line, the logic model, or we say logistic model, and this model they capture most of the observation. So and we can furtherly to extend this function. Remember I mentioned before, when we ask people about their wage level, because maybe some private personal information, they do not share their exact wage number to us, or they do not want to share this information in the questionnaire. So we can try to find another question. We set some interval, some option, and they chose to describe or to disclose some information about this wage level. So we can ask that if your wage number is lower than 10,000, or your wage level is larger than 30,000. And so we can use this option to capture or to describe the pattern. Then we can describe this figure like this one. In the slides, because y only equal to 0 or 1, so we only have two numbers. If we use this option, because they have more action can describe. So the first one, for example, y equal to 1, which means their wage level is lower or equal to 10,000, and y equal to 3, which means $30,000. And if y larger than 4, which maybe means their wage level is larger than 40,000, and then we can use this option. We use this option and to find this pattern. And Then this figure we call ordered number. In Chinese, we say this is a 排序 order, 排序, and this order, which is a large or which is meaningful for the large or large value or less value, and this is a binary choice or a multiple choice. Multiple choice. So back to this slide. In this example, is a situation or circumstances. I assume we ask these people, what's your choice? Do you want to go to further study in the school, or do you want to graduate from the university and go to the labor market? 1 is for further study, and 0, which means you go to the labor market. And this one, I ask these people, what your wage level in the last week? What's your wage level in the last week? And 1 means this level. The 1 means their wage level is the lowest interval, and for example 4 means the highest interval. So this number, this number is like they has a one step, and we can use the estimation or the empirical model to find use this estimation to find the impacts of the independent variable X on dependent variable Y. So this is another example. 债券平等. In Journal of Finance, because we know the performance of this bonus, of these bonds, these financial bonds, usually we say AAA, which means they have the best performance, and triple B, they may have the less or not good performance. So we can use this one. For example, AAA, for example 4. If Y equal to 4, which means this number, this financial bonds, they have a better performance, and the Y equal to 1, which means these financial bonds, they have a less or the worst performance. So you can find this slice, Y equals 1, 2, 3, 4, and when the number goes to larger, which means this financial bonds has a better performance, and the number goes to less, and the financial bonds has a worse performance. So we can furtherly to calculate the probability. The first one, probability Y equal to 1, which means in the sample we collect, the worst performance, when we capture or when we take one sample or one financial bonds, and the probability of the worst performance of the sample we take to the sample size. So, and Y probability Y equal to 4. The situation Y equal to 4, the probability is like this, which means the sample we get from the collection, and the probability, which this probability means the best performance of these financial bonds. And the next is this example is like the promotion. For example, in China or in 30 years ago Taiwan, basically public officials, they if they have a party, they are one member of the party, they may have a promotion incentive, or they may have better probability to promotion in the public labor market. So we can use this order data. This order data to find does this person into the party. If he into the party, then we can find whether the impact of the party member or this party affects their promotion or their other performance. For example, their economic performance or their work efficiency or other factors. Okay, this is the limited data, and then we introduce another. Data scale. This is a figure. The horizontal line. Horizontal line is the numbers we collect, and the vertical line. The vertical line means the number we collect, and the horizontal line is the interval or the situation or the number we define, the value we define. For example, if we ask or we take a questionnaire to ask our students in the NKUST, and we ask how many times do you visit or travel to Japan in the last year? So in our collection, we can find this. Most sample, they feel they are the sample basically they largely concentrate on the 0 or on the 1, which means this student or these people, when we ask them how many times do you travel or tourist in Japan in the last year, many people they have 0 time or they go to one time, and they may have some people last year go to Japan 2 or 3 times, but very few people go to Japan with, for example, 10 times, 20 times, or 30 times. So we can find this is like the health share, health bill share. Compared with the normal distribution. Normal distribution, we said this is like normal distribution. This is bell shape, and in this figure, they may like this one, or this area. Because when we ask this student how many times when you travel or tourist to Japan, most is go to 0 time or 1 time, and fewer people go to 2 or 3 times, and most people is concentrated during this interval, and the very few sample they are in this area. And we say this is a count data because our question is we try to count, we try to collect the count character. When how many times do you travel to somewhere or to some specific area listing? So this is a count data. So in this course, we introduce the first thing when we face the limited data. When we face the limited data, because we cannot find the exact number, so we need to ask some question that to push these people when they take this questionnaire, they want to share some limited personal information, and because this is a personal, this is a limited information, so we can only get 0, 1, or 1, 2, 3, 4, something like this one-step database. So we cannot use the linear function because this linear function they have a larger error term. Because of these error terms, so we need to use another estimation. It's like probability estimation, probability regression, or the logic, or we sometimes call this logistic regression to capture this figure. And because this estimation can capture lower error term in the estimation process. And the next we introduce, if we can define different number, then we can try to find the impact of the independent variable, undependent variable. In this example, we can find some character of the financial bond. What's the impact of this independent variable on bond's performance? And the next, we introduce the count data. And finally, because we introduce this ordered data, and you can find in this slides, when we introduce the ordered data, the number means the value. When the number goes higher, which means this value is larger. And this slide, we call this a sequential. What is a sequential? Sequential is, for example, in this area, in this step, if these public officials, their promotion stop because they do not go to the political party. For example, in China, basically, most public officials, they need to go to the Chinese Communist member. So if they do not become one of the party member, their promotion probability basically stop. So, and let's stop, this outcome will not happen. So sequential, which means if the first step complete, then we can go to the next move. And if the first step, they do not go to the right side path, so their path is stopped. So the next example, similar example, is the auction, house auction. The courts legally declare the sentence. They try to set auction to sell the house. In the first auction, if this house is sold, then the economic activity is stopped. If in the first auction they do not successfully sell this house, then they will go to the second auction. Second auction, if they successfully to sell, then this auction is stopped. If they do not sell the auction, sell this house, then they go to the third action. Third auction, or the fourth auction, or fifth auction. So the sequential, the difference between sequential and the ordered data, difference between these two things is when the sequential, they go to some specific situation, their move will stop, and the next path will not happen. And the ordered data, they just try to define the number and use this number to represent the values, the larger value or the lower value, like this thing. OK。那可以帮我关掉。So the first course we finished. We take some rest.